Welcome to the NSF webinar on the testing to EN 12897 2016 plus Amendment 1 2020. The title of this standard is Water Supply Specification for Indirectly Heated, Unvented Closed Storage Water Heaters. Throughout the webinar, we'll be covering a number of areas, the first being the background to testing to the standard, the UK building regulations requirements, scope of EN 12897, instructional and mechanical requirements, marketing requirements, evaluation and conformity, and then lastly the technical document requirements. My name is Ian Broad. I'm the Senior Technical Specialist at the NSF Wales Laboratory in the UK. A bit of career then. So I started work with NSF in the NSF years ago. Initially, I was involved in the installation of services and the first test rigs in the lab. And then during my time here, I've advanced through various roles in many areas, including pipe testing, water regulations testing, thermostatic mixing valves, or TMVs as they're known, and unvented cylinder testing. I've also been involved in many different types of bespoke testing projects with the product evaluation department. This includes the design and build and commissioning of new rigs to allow for various types of testing to be conducted. In addition to this, I also train then the staff in the setting up, operating and test procedures for a wide range of fittings. Prior to joining NSF, I undertook a 5-year plumbing apprenticeship, gained an advanced craft certificate in plumbing, and subsequently worked as a qualified plumber with the UK National Health Service. During this time, I gained vast knowledge working on and installing water, drainage, and steam systems within hospitals and various types of healthcare premises. The background to the testing then to EN 12897. So in the UK, the safety of hot water systems is covered by the requirements of the building regulations. Hot water supply and systems is covered by the approved document G3. This states, a hot water system that has a hot water storage vessel should incorporate precautions to A. Prevent the temperature of the stored water in the vessel at any time exceeding 100 degrees C, and B. To ensure that any discharge from safety devices is safely conveyed to where it is visible but will not cause of danger to persons in or about the building. Clause 310 of the approved document states that a hot water system should be designed and installed in accordance with BS 6700 or BS EN 12897. Clause 317 states to minimize the danger from excessive pressure, unvented hot water storage systems should incorporate a minimum of 2 independent safety devices. These should be in addition to any thermostat provided to control the desired temperature of the stored water. And safety devices as well as the control stat. Clause 318 states that an acceptable approach might consist of resetting energy cutout to disconnect the supply of heat to the storage vessel in the event of the storage system overheating, and 2, then a temperature relief valve or combined temperature and pressure relief valve to safely discharge the water in the event of serious overheating. Alternative approaches to this are acceptable, provide an equivalent degree of safety. The general requirements then is that an unvented hot water storage system should be in the form of a proprietary unit or package A unit, the hot water system, having the safety devices listed in the approved document G3, so these being the non-self-resetting energy cutout wired to a primary circuit motorized valve and a temperature and pressure relief valve, and all of the so this will then contain the strainer, pressure reducing valve, single check valve, expansion relief valve, and expansion vessel fitted by the manufacturer. So this is known as a pre-plumbed unit. So everything pre-plumbed, and it's down to the plumber then to connect the cold mains, the hot outlet, and the discharge from the tin dishes then. System having the safety devices as mentioned above, so the non-self-resetting energy cutout and the temperature and pressure relief valve, together they are factory fitted and then supplied together with a kit containing all the other applicable operating devices, so your cold mains inlet group then. And as I said then, so that's supplied then, the kit will have all the operating devices in the box that's supplied to site with the cylinder, with the temperature and pressure relief valve and the the energy cutout factory fitted. The scope of BS 12897 states that the standard specifies the constructional and performance requirements and methods of test for indirectly heated, unvented closed storage water heaters suitable for connection to a water supply at a pressure between 0.5 bar and 10 bar, and are fitted with control and safety devices designed to prevent the temperature of the stored water from reaching 95 degrees. Though, when tested to the function of safety test, as stated in Annex A5 of the standard, the criteria states that the temperature in the top of the storage water heater shall not reach 100 degrees C. In December 2021, NSF Wales updated its UKAS accreditation for testing to the requirements of the latest edition of the standard. Heaters tested to BS EN 12897 will show compliance with Building Regulation G3. Section 4.1 of the standard then covers the constructional requirements. So clause 411 is inspection access. Unvented storage water heaters should be provided with means of internal inspection. This can also be achieved by using a connection intended and dimensioned for other purposes, where the use of a suitable inspection instrument such as an endoscope is acceptable. Clause 412, draining. So unvented storage water heaters should permit in situ draining. The method of draining should be given in the manufacturer's instructions. Clause 413, hydraulic connections. So hydraulic connections should be of a type that allows the storage water heater to be disconnected from the pipework. Normal arrangements are compression fittings, threaded connections. Clause 4.2 is temperature control. So the temperature of the stored drinking water should be regulated either by control of the heat source or sources, or by control of the water heater. Section 4.3, clause 431, so the pressure resistance of the water storage vessel. So this is the secondary circuit. The water heater should withstand a pressure of 2 times the maximum design pressure for a period of not less than 10 minutes without showing any signs of leakage or cracking. The maximum design pressure is the maximum pressure that the storage heater is designed to be subjected to in use. This will be the pressure that the expansion relief valve is set to. So for instance, if there's a 6 bar expansion relief valve fitted to the unit, then the test pressure will be 12 bar, twice the expansion relief valve set in. Clause 432 pressure resistance of primary heater or coil. Each primary heater or each coil should withstand a pressure of 2 times the maximum design pressure as specified by the manufacturer for a period of not less than 10 minutes without showing any signs of leakage or cracking. So if there's multiple coils within the cylinder and there's different pressure ratings, then these pressure ratings will need to be stipulated on the label as well. And as I said, each coil then will be tested to twice that working pressure. Clause 433 then is durability. So the water heaters should be tested for durability by pressure cycle testing. Water heaters without inlet pressure and system expansion control. So these designs of cylinders should be subjected to either 20,000 cycles at 1.2 times the maximum design pressure or 100,000 cycles at the maximum design pressure. But for systems in the UK, these are covered by the next group. So these are water heaters with inlet pressure and system expansion control. These designs of cylinders should be subjected to either 20,000 cycles at 1.5 times the maximum inlet pressure or 100,000 cycles at 1.3 times the maximum inlet pressure. Maximum inlet pressure is the set pressure of the pressure reducing valve fitted or supplied with the cylinder. At a 55-second cycle time, a 20,000 cycle test would take approximately 13 days to complete, and a 100,000 cycle test would take approximately 64 days to complete. The requirement of the test then is that the cylinder should show no signs of leakage or cracking during or after test. You can see here this is the durability test profile. So P1 is the minimum inlet pressure as defined in the technical document, or 1 bar, whichever is the lower value. And P2 is the test pressure. Depending then how many cycles, the 20,000 or 100,000 cycle test is selected, would depend on the pressure P2. So there's a ramp rise test between T1, and it's got to reach the test pressure within 15 to 30 seconds. The pressure hold time then, T2, and this is for a time period of between 15 and 20 seconds. But the overall time then for the full cycle, ramp up, hold time, and ramp down has got to be between 45 and 60 seconds. Clause 441 of the standard then covers the general requirements. Control and safety devices shall operate in the following sequence. First, the thermostatic control device or the controlled thermostat must operate. Secondly, then, the energy cutout device or the non-self-resetting energy cutout must operate. And third, then, where required, a temperature and pressure relief valve or safety relief valve. It is a requirement in the building regulations that a temperature and pressure relief valve must be factory fitted. Water heaters shall, where required, either be factory fitted, supplied with, or fitted in accordance with the manufacturer's instructions, with all devices necessary for the operation of the water heater and the prevention of contamination of the drinking water supply. All tests, unless specified within the test method, shall be carried out with all devices necessary to control the temperature of the water and the prevention of contamination of the water supply. Clause 442, so this covers the energy cutout device. So the water heater should be fitted with one or more non-self-resetting energy cutouts conforming to EN 60730 2/9, connected to the heat source to ensure that the heat input is interrupted in the event of failure of the controlled thermostat and before the temperature of the stored water reaches 95 degrees. Clause 443 is the temperature relief valve. So temperature and pressure relief valve shall conform to EN 4. temperature of the stored water from exceeding 100 degrees C. Clause 444, pressure relief or expansion relief. Where required, water heaters should be fitted on the cold water inlet with either an expansion valve, an expansion group, a pressure safety valve, or a hydraulic safety group conforming to the listed European standards there. The majority of the cylinders in the UK are supplied with expansion groups and said they contain all the necessary safety devices then. Clause 445, pressure reducing valve. So where required, a pressure reducing valve conforming to EN 1567 shall be used. Clause 446 is the provision for expansion. So where it is a local requirement that expanded water must be contained within the hot water system, water heaters shall either have an expansion capability within the storage vessel, or internal expansion or bubble top designs as they're also known as, or B, be supplied with or fitted in accordance with the manufacturer's instructions with an expansion vessel, and said these are normally known then as external expansion units. It is a requirement of the UK Water Supply Water Fittings Regulations 1999 that no water fitting shall waste, misuse, unduly consume or contaminate the water supplied by the undertaker. Thus, for approval in the UK, unvented cylinders must be designed with provision to accommodate expansion. So, section 4.4, safety equipment. So 4.46, provision of expansion. So to test the design of the internal expansion system within an unvented cylinder range, a selected cylinder within the range, normally a 200-litre cylinder, will need to undertake an endurance test. The conditions of the endurance test is 7, test of air bubble unvented or water storage systems. This test subjects the test cylinder to daily draw-off cycles at various flow rates for a total of 380 cycles. There are 2 draw-off profile options to choose from. Option A test takes 95 days and option B test takes 64 days. NSF is UKAS accredited to undertake this test as part of the approval testing of unvented cylinders. Clause 447, backflow prevention. So where required, a protected device against the backflow conforming to EN 1717 should be used. It is a requirement in the UK that an approved check valve is fitted in the cold inlet to each unvented cylinder that complies with the Water Supply Water Fittings Regulations 1999. Section 5 is the marking requirements. Water heaters should be permanently marked by means of a plate or a label to be visible after installation. As a minimum, the following information, so number and year of the standard, manufacturer's name, trademark or identification mark, manufacturing number or serial number indicating the year of manufacture, maximum design pressure of the drinking water side or the secondary circuit, and maximum design pressure of the heating side or the coil or coils. The rated storage volume, the rated volume of the heat exchanger or heat exchangers, and the standard heat loss in kilowatt hours per 24 hours or watts. Note that in addition, it is a requirement of the Building Regulation G3 that the warning labels shown should also be indelibly marked and visible after installation. Section 6 is the evaluation and conformity. Clause 611, compliance testing. So compliance of the product with the requirements of the European standard and with the stated values should be demonstrated by initial type testing and factory production control by the manufacturer, including product assessment. Section 6.2 then covers the initial type testing. Clause 6.2.2 is actual volume. So the actual volume should be determined using a suitable measuring or calculation technique with an accuracy of plus or minus 1%. This may be done by weighing the heater empty and then full of water and calculating the volume of the water. Where a water heater has an internal airspace, this test should be done with the storage water heater at normal maximum inlet pressure. So example, at the set pressure of the pressure reducing valve. For heaters with internal expansion, we would install the heater in accordance with the manufacturer's installation instructions with the supplied operating device and wait for the water pressure within the heater to fully stabilize to its normal maximum inlet pressure, so the normal working pressure, before calculating the actual volume. NSF uses both the weighing method, and for larger volume heaters, we also use a calibrated water meter. Clause 6.2.3 is the rated storage volume. So the volumes as specified in the manual should be within the percentage tolerances as listed in the table as shown. So as I said, you're allowed then a tolerance on your actual water volumes, and that's got to be within that tolerance bands then shown in the table. So clause 6.2.4 is the hot water volume. So the hot water volume should be determined according to the procedure described in Annex A of the standard. The test cylinder is set up in our test rig as detailed above and is filled with water at a temperature of between 8 and 18 degrees C. A primary flow temperature at 70 degrees above the initial is then passed through the coil at a default flow rate of 15 litres a minute. This default flow rate can be changed if the manufacturer specifies a different flow rate, then that can be set for this test. But that flow rate then will need to be marked on the label to show that those heat up times have been obtained using that specified flow rate. The cylinder is heated until the temperature at the top of the cylinder, capital T2, reaches a temperature of 50 degrees above the initial cold water start temperature. The time taken is recorded as the reheat time. You can see the diagram of the setup then. E is your bulk heat store. You've then got a circulator, a flow meter in the primary loop, and control valves to accurately adjust the flow rate. You've got pressure gauges on your as close as possible to the coil connections to draw off pipe them again with another flow meter and control valves to accurately control the draw off rate. And that then goes into a container on a weigh platform. So before opening the hot outlet valve to draw off the hot water at a preset flow rate as stated in Table A2 of the standard. The flow rates range between 9 litres a minute and 60 litres a minute depending on the cylinder capacity. When the discharge water temperature drops to the initial cold water start temperature, theta set plus 30 degrees, the hot outlet valve is immediately closed. The temperature against time to allow for the primary heating power in kilowatts to be calculated, and for the equivalent volume of the mixed water available at 40 degrees to also be calculated. The requirement of this test then is that the primary heating power, kilowatt rating of the coil, is to be printed on the label and in the operating instructions. At least 75% of the cylinder's actual capacity should be drawn off as hot water at the initial cold water start temperature, theta C plus 30 degrees C or above, and the mixed water volume at 40 degrees, V40, should be declared in the assembly and maintenance instructions. Also, the heat exchanger pressure drop should also be recorded during the test. Clause 6.2.8 then covers the standing heat loss test. The standing heat loss test is carried out in accordance with Annex B of the standard, and that is for the purpose of type testing, a special storage water heater is used, which is identical to the indirect storage water heater, except that the primary heater or the coil may be omitted. For test purposes, the storage water heater is fitted with an electric element or immersion heater at the lowest possible point at least 85% of the storage water heater's content by volume should be above this heater. If the storage water heater already has a backup immersion heater that meets the above condition and it heats greater than or equal to 85% of the storage water heater's content, then this can be used for the test. If the primary heater or coils is omitted, the primary heater exchanger connection stub connections should remain. As I said, these would affect the test, so they need to be welded onto the shell. The storage water heater should be tested with factory-fitted safety devices such as temperature relief valves in place. These valves may be insulated if this is the normal practice recommended by the manufacturer for installation. The immersion heater used for testing should normally be a 3 kilowatt, but for storage water heaters of above 250 litres capacity, a higher output may be used if normally specified by the manufacturer for backup purposes. The storage water heater should be provided with a means of filling with cold water and a means of accommodating or discharging expansion water. All test rig pipework and connections should be insulated with an insulation material with a thermal conductivity and thickness given in Table B1 of the standard, and as shown below. So if the connection pipework is greater than or equal to 22 mil, the thickness of the insulation needs to be 20 mil. For pipework then greater than 22 and equal to or less than 35 millimeters, it's a 30 mil, and so on then, as listed in the table. Units designed for floor mounting should be mounted on a base of at least 20 millimeter thick medium density fiberboard at a height of at least 50 millimeters above floor level and positioned such that there is at least 250 millimeters behind the unit and at least 700 millimeters from any wall or other vertical surface. In order to measure the temperature of the stored water, a sensor T4 should be positioned such as to register the temperature at a point 25 plus or minus 20 mil. External expansion cylinders, we actually measure the distance is specified to the settled level of the water. We would use the thermostat pocket, but otherwise we would ask for the manufacturer to put a special stub connection 25 mil below the settled water level, so we can accurately measure this water temperature then in the correct position. 3 additional sensors, T1, T2 and T3, are required to measure the ambient temperature. They should be positioned at a height of halfway up the storage water heater wall and at a distance of 350 plus or minus 25 millimeters from the exterior of the unit under test. These sensors should be positioned at the sides and front of the unit as shown. So you can see them there then, T1, T2, T3, just positioned around then at the correct height and distance away. During the test, the ambient temperature as measured by the readings taken at T1, T2 and T3 should be 20 degrees plus or minus 3 degrees. All 4 sensors are connected to a data logging device that records the individual temperatures at intervals of 5 minutes. In order to measure the electricity consumption, we connect the supply of the immersion heater via a UKAS calibrated kilowatt-hour meter. The procedure then, so the cylinder is filled and all air is expelled. It's important to get all the air out of the cylinder as this will affect the test. So the outlet valve is then closed and the immersion heater is then switched on, and the temperature of the stored water adjusted to the temperature of 65 plus or minus 3 degrees. The test rig is then switched on and the temperatures and the kilowatt-hour readings are data logged for the full duration of the test. The test cylinder is then allowed to stabilize under thermostatic control for a period of 24 hours. After 24 hours, the test rig creates a log and logs of the date, time and kilowatt-hour stamps to mark the start of the test. The test regime continues until the standing heat loss is within 3% for at least 2 successive 24-hour periods. The standing heat loss is taken as the mean of these results. If it's not possible to achieve a variation of less than 3% between the results, the test is continued for at least 168 hours, so a further 7 days, and the results of the last 3 24-hour periods are recorded. The standing heat loss is then taken as the mean of these 3 results. The readings from the data logger are then analysed and the overall average differential is calculated. Finally, a correction is made for the difference between the nominal differential of 45 degrees and the measured average differential as detailed in the standard. The final figure is rounded down for declaration purposes to decimal places. For eco-labelling purposes, the standing heat loss is required in watts, rounded to the nearest whole number. The requirement then is that the standing heat loss in kilowatt hours per 24 hours or watts is required to be printed on the label. 6.2 then, so 6.2.10 is the temperature control devices. So if the water heater is supplied with a temperature control device, it should be tested in accordance with the procedure in accordance with Annex A5. So note, it's a local requirement that a temperature and pressure relief valve or a no less effective device is required to be factory fitted to all unvented hot water storage cylinders in the UK to prevent the water at the top of the cylinder from at any time exceeding 99 degrees. So A5 then is the function of safety device. So the storage water heater should be set up as shown, where an electric immersion heater or heating are included in the specification. They should also be fitted. The wiring to the control thermostat and energy cutouts should be disconnected, and means such as an electrical test meter or LED indication lamps provided to measure the temperature at which these contacts operate during the test, and the operating temperatures should be recorded. The flow temperature from the primary heat source should be set to a temperature of 110 plus or minus 2 degrees with a flow rate of 15 litres a minute, and the storage water heater heated as before by means of the primary heater or the coil or coils. Note that if the heater is of a twin or triple coil design, then each coil will need to be supplied with a flow temperature from individual primary heat sources that should each be set at a temperature of 110 plus or minus 2, also with a flow rate of 15 litres a minute. If an auxiliary immersion heater is fitted, then the test should be performed using direct electrical input in addition to the input from the primary heaters or coils. In this case, the thermostat and the cutouts to be tested are those which control the electrical input to the element. The heater needs to be tested in the worst possible failure conditions to ensure that the thermostats are positioned to operate correctly and to ensure that the temperature and pressure relief valve is sized and positioned in the heater to ensure that at no time the water in the top of that heater exceeds 99 degrees. So A53 then set the control thermostat to maximum and record the temperature at which it deactivates the energy supply. At this point, the non-self-resetting energy cutouts shall not have operated. The heating should continue until the non-self-resetting energy cutouts operate. This temperature should be recorded. At this point, the temperature relief valve shall not have operated. Heating shall then continue until the temperature relief valve operates. At this point, the temperature in the stored water heater, as measured at T2, shall not reach 100 degrees C. With the heat source still connected, the test shall continue until the temperature relief valve eventually closes. The test shall then be allowed to continue until a total of 2 opening and closing cycles of the temperature and pressure relief valve have been completed. The requirements then is that the control and high limit non-self-resetting energy cutouts must operate in the correct sequence, and the temperature and pressure relief valve should be sized and positioned in the water heater so that it prevents the temperature of the stored water, measured at T2 in the top of the cylinder, from reaching 100 degrees C during both cycles. The maximum temperature reached at T2 during each of the 2 cycles should be recorded. Coming on to section 7 then, this covers the technical documentation requirements. So each water heater should be supplied with a set of assembly instructions along with operating and servicing recommendations, including maintenance instructions. So the assembly and maintenance instructions shall include, as a minimum, the following information. So technical data, including maximum inlet pressure, so rated pressure of the primary and the secondary system in pascals or bar, maximum operating temperature of the heating fluid in degrees C, type of corrosion protection and maintenance, the rated storage volume of the water heater, location and nominal diameter of all the connections, accommodation of expansion water method, pressure drop through the primary heater, primary flow rate information, diagram showing positions of the devices, so the draining tap, etc., and the V40 hot water volume in litres. The assembly instructions shall also include a minimum of the following, so installation instructions with a recommendation on mounting surfaces, distance from walls and protection with regards to frost, method for external pipework connection, types and size of safety devices and drain tap, necessary temperature control devices, including the wiring diagram, and types of inspection access if provided. Note that in addition, it is a requirement of the Building Regulation G3 that the full information from the approved document with regards to the discharge pipes from safety devices, so that's clause 3.50 through to and including clause 363, including diagram 1 and table 3.1 from the document, must be included in the assembly instructions. This information details how the discharge from safety devices can be safely conveyed to where it is visible, but will not cause a danger to persons in or about the building. Technical, so the operating instructions N73. The operating instructions shall include, as a minimum, the following information: the name and address of the manufacturer, market information given in clause 5 of the standard, and information on recommended maintenance, and information on disassembly, recycling, and disposal of the product. Okay, thank you for attending this webinar. I hope you found it useful and helpful. I'll now hand you over to my colleague, Sarah Sperano, for any questions you may have.
Thank you, Ian, and thank you for everyone attending NSF's webinar today. We are going to start the Q&A portion. Any questions you have can be submitted via the chat box on the right-hand side of your screen. Looks like we have a few questions coming in. So first one for you, Ian. For a cylinder designed with 2 coils, does each coil require its own non-self-resetting cutout?
Yes, it's a requirement that each individual heat source has its own non-self-resetting cutout. So if it's a twin coil cylinder, there needs to be 2 non-self-resetting cutouts fitted to the cylinder, and these need to be linked then to individual motorized valves in each of the coils. Yes.
Have you ever had a cylinder reach 99 degrees C while conducting the function of safety devices test?
Yes, we have on a couple of occasions, and yes, as I said, when we're running this test, things can get very tense, as I said, when it's getting up to 96, 97, 98 degrees. So there's a minimum of 2 technicians that need to conduct this test for safety reasons. And yes, once the temperature gets to 99 degrees, then all of the heat inputs must be instantly isolated, and the cylinder allowed to cool down then. So yes, we have had a number of occasions where this has occurred.
Okay, perfect. How many years has unvented heater testing been conducted at the NSF Wales laboratory?
This laboratory was one of the first laboratories to set up and get accreditation for UKAS, accreditation for unvented testing. And I believe we issued our first test certificate back in 1995. I was part of the team then who wrote the procedures and set up the test rigs. So yes, it's over 25 years we've actually been conducting this type of testing. Yeah.
Okay, great. So that is all the questions we have at the moment. I want to remind everyone that you can continue to submit questions via the chat box even after the webinar is complete. Those questions will go directly to our team, and we will follow up with you as soon as possible. If you'd prefer to reach out directly to an NSF team member, we have Mosan listed here. Mosan is the Senior Account Manager for our Wales lab, and he would be happy to answer any questions that you have. Another reminder, all attendees on today's webinar will receive an email with the recording of the webinar and the slides in the next 24 hours. And thank you again to Ian and for everyone joining us today, and I hope you have a great rest of your day.
Thank you. Thank you, Sarah.